This is the fourth video on section 2.1, vectors. And we're going to start by talking about what it means for two vectors to be parallel. Definition 29 says that two vectors are parallel if there is a scalar alpha such that alpha v is equal to w. Another way to define parallel vectors is two vectors are parallel if they either have the same direction or they have exact opposite directions. That's another way to define parallel vectors. Example 30 gives us two vectors and asks, are they parallel or not? So is the vector 104 parallel to the vector 308? Turns out the answer is no. Why? Well, let's suppose that they are. So if w is alpha v, then what happens? Well, 3 is alpha times 1. Because if w is alpha v, so w is alpha times v, so we look at the first component, 3 is alpha times 1. Well, if 3 is alpha times 1, that means alpha is 3. However, now look at the third component. 3 times 4 is not equal to 8. And so the two vectors are not parallel. If this were 208 instead, then 2v would equal w and they would be parallel. So v is parallel to the vector 208, but it's not parallel to the vector 308. Last thing I want to talk about are what we call the standard basis vectors in v2 and v3. So in v2 we have the vector I, which is 1, 0, and we have the vector j, which is 0, 1. If you take any vector in v2, you can write it as an arithmetic combination of I and j. The way we usually say that in linear algebra is we write it as a linear combination of I and j. But you can use vector arithmetic to write any vector in v2 in terms of I and j. So the vector ab is going to be ai plus bj. In v3, our standard unit vectors are ij and k, written this way. And again, you can take any vector in v3 and write it in terms of ij and k. Now, notice we're using the same notation, but this is generally not ambiguous because we usually know whether we're in v2 or v3. So if we're working in v2, I is this vector. If we're working in v3, I is this vector.